In this video, you're gonna learn about arrays in C++. Here are some key points on which we will stick around throughout this video. The first one, what are arrays? And now the second one, how arrays are stored in memory. And the third, how arrays work in programming. At last, we'll see how all this looks like in the real code in C++ language. So let's see, what are the arrays? Array is a simple data structure which consists of collection of elements having indexed positions. Now what's that mean? Let's understand this with a simple illustration. Suppose that we have given a set of elements arranged in a linear way, and we have to identify them uniquely. So what we can do? We have to apply indexing to each of these elements to identify them uniquely. Let's 1, 2, 3, 4, 5, 6, 7, 8, 9. And this arrangement having indexing to all these elements is called array of 9 elements. Later in this video, you will see that the indexing of these set of elements in a given array will begin with 0. Now the question is, how to store an array in computer memory? To understand this, let's take an example that we have given a set of 6 elements, each of the type integer, having indices 1, 2, 3, 4, 5, 6. And this is called array of elements of type integer. And each of these elements will have the size of 4 bytes. Computer memory is just a linear arrangement of bytes. Here, each byte is represented by small blocks. If you want to store the first element of our array, which is of size 4 byte, into our computer memory, it would require 4 bytes of memory. To store all the elements of this array in this linear memory, we have to divide this memory into 6 groups, and each group having 4 bytes. Now the next question is how we can access them and work with the elements which are stored in computer memory. The answer is with the help of pointers. To understand this, suppose that we have again the linear memory divided into 6 groups, and each group has 4 bytes, and each byte is indexed from 1 to 24. Suppose that the address of the first byte is 4000. To work with this memory buffer, we would require a pointer to integer. Let's define it as an integer pointer named as byte1 address. To access the first element of our array, we have to assign the address of the first byte of the first element to our pointer. Now, if you want to read the first byte of our first element of the array, you have to dereference our byte1 address pointer. And if you want to read the rest of the bytes of the element, we have to increase the byte1 address by 1 and by 2 by 3 for accessing the byte 1, byte 2, byte 3, byte 4. And this will make up our first element. Similar to this way, if you want to access the second element of our array, we have to assign the address of the first byte of our second element to our byte1 address pointer. And to access the second byte of the second element, we have to increase our byte1 address by 1, and so on. Now we can access all the bytes of the second element, byte number 5, byte number 6, byte number 7, byte number 8. Now all these 4 bytes will make up our second element, and now accessed. And we can notice that there is a common pattern to access all those elements of our array. So what's the pattern is? Let's see. Suppose that we want to access the first element of our array, and then we have to assign the address of the first byte of our first element to byte1 address pointer. And now we can access all the rest of the bytes of our first element of the array. Similar to this way, If you want to access the second element, then we have to assign the address of the first byte of the second element of our array to byte 1 address pointer. And now we can access the other rest of the bytes of the second element. And so on, we can do this for the rest of the elements of our array. And now we can write the expression to get the address of the first byte of the element at an index t. Now we can also transform this expression to a simple one, starting t with 0. And this is the reason why the array indexing is based on 0. We can also treat the memory as a byte array. And now let's change the indexing of this byte array starting with 0. Now pay attention to our expression. Here, 4000, which is our address of the first byte of the entire array, this is called the base address of our array. Now pay attention at 4, which is the size of integer. More generally, it is the size of the elements present in our array. It can be the size of float, or size of double, or size of character, right? And now we have understood all the terminologies. Let's write the generic expression. And finally, we have derived the expression to calculate the address of the first byte of the element at an index t in a given array. And now let's see how we can define and declare arrays in C++ language. And later in this video, you will learn more about syntaxes of declaring arrays and initializing them. There are many syntaxes possible, yes. But here we will take the more descriptive syntax of declaring and defining arrays. Okay, first of all, you have to specify the data type of your elements present in your array. It can be integer, float, character, even double. And then you have to specify the name of your array. It can be array name, or integer list, or list of elements, or even doubles. Note that it is not a double keyword, okay? And then you have to specify the number of elements present in your array in square brackets. It is 6. Or more syntactically, you can write like this. And then you have to write the equal to sign. And finally, you have to write the elements present in your array in curly braces, separating with comma operator. And now you have done. A question might have arisen in your mind that where is the pointer in this array declaration? The answer to this question relies on the expansion of this declaration. Here, this is called constant pointer, which holds the base address of the array. And each element can be accessed using the indexing operator. Actually, these are the shorthands for the expansions given on the left side. You can notice that we have substituted t with 0, and here we have substituted t with 1. Okay, now let's get into the real code. So here we are. First of all, you have to write the data type of your elements present in your array. Let's integer. And then you have to write the name of your array. For example, let's integers. Okay. And then in square brackets, you have to write the number of elements that your array is going to have. And then write equal to sign. And then initialize your array. So I am writing the elements of the array. Note that you can't exceed the number of elements in this curly braces than the specified in your square bracket. If you want to write one more elements like 67, then you have to write here 4. Be careful about that, okay? Okay. The one thing to note here is that if you have already specified all the elements present in your array, then the compiler can automatically reduce the number of elements present in your array. That means you don't have to specify any value here in the square bracket. You can leave this here, okay? You can omit this. Okay, this is the second type of declaration, right? The other way of declaring arrays is that you can have the like float. This is the data type of your array, and name this array as floats, and then write the number of elements, let's 3. And then we can assign values to each of these elements by accessing them by indexing operator. For example, floats 0. Okay, we have accessed the first element and then write the value, for example 3.4f, and then we have accessed the second element and then write the value 4.5f, and at last we have to write the 2 in the square brackets and then write some value. And note that we can't write it as 3 because it is our fourth element, whereas this array can only contain 3 elements. So be careful about that. Okay, this is pretty much for now. I will meet you in the next video.